Hello everyone, this is part 2 of final exam review. Now we are going to start off with permutation and combination. So here, what are your chances of winning a mega lottery if you have to pick one mega number from 1 to 40 and 5 regular numbers from 1 to 56? So these are two independent events you can think of. One is selecting the mega, other is selecting the other 5 digits, and please do keep in mind that the the order of events, order of the numbers does not matter. So in which order you pick the numbers, that's not important. Okay. So event A is selecting the mega, which could happen in how many ways? It could happen 46 C1 combination, and even B could happen in how many ways? 56 C, you select how many numbers? 5, so C5. So this is the number of ways you can pick the mega. This is the number of ways you can pick the other 5 digits or 5 numbers rather. So together they can happen in these times this many ways. Okay, fundamental counting principle. So these are the total number of ways you can select the Mega Millions lottery tickets. Now out of all of these there will be only one winner, so your chances of winning it is probably going to be 1 out of this. That means 1 over whatever this number, some number n. So if you simplify it, you will get some number. And remember, the formula for combination is NCR is equal to n factorial over r factorial times n minus r factorial, and that's what it is. And what is the probability of giving birth to all girls if a couple want to have 5 babies over the next 5 years? So these are 5 independent events again. So each year there are 2 possibilities. So over 5 years there will be 2 to the power 5 different possibilities. You can think of it as such: A1, A2, A3, A4 and A5. Okay, these are the events. So each year you could have 2 outcomes, like either boy or a girl, same for each year. That's how you get the 2 to the power 5. However, if you write it out, you don't have to write it out really, all girls, right? So there could be only one way of getting all girls. So obviously your chances of getting all girls is 1 out of that many. Binomial distribution, again, formula for binomial distribution is this: probability of x is equal to ncx times p to the power x times 1 minus p to the power n minus x. So you have to use this formula to find out all the different probabilities and then answer the following questions. Here n is going to be the number of patients, 5. P is the probability of success, which is 70%, 0.7, and x would be one of these values. Okay, 0, 1, 2, 3, 4, 5. X couldn't be 6 because the maximum number of patients who received the drug is 5, right? So probably that 5 patients are cured or extend their lives rather is going to be the most that you could have, right? So it couldn't be more than 5. So that's what it is. And then you just answer the following questions based on this. So let's go ahead, and all of these are like this. So Poisson distribution, very similar, nothing really magical here. Probability of x is equal to mu to the power x times e to the power negative mu over x factorial. X is a discrete probability here, so X is a discrete random variable, so X could be 0, 1, 2, 3. So make sure that you convert it into the correct average, right, or mu, or the expected value. 3600 36 okay, so there were 3600 patients who visited emergency medical care facility over 1 year period. Find the probability that tomorrow, so you have to take this 3600 and divide it by 365, because there are 365 days. So that's your mu, or expected number of patients that's supposed to come by. Now the next one is again expected value problem. Remember, expected value E of x for discrete cases is gonna be summation x times P of x. So you have two investment products here where you invest $10,000. Okay, so now you have to select which one are you gonna invest in. Are you gonna invest in first bond, or you're gonna invest in the second bond? One gives 7% return with a default rate of 4%. So you have to create a table the way we did it in the we did it in the class. So it's gonna be x times P of x, right here, x times P of x. Okay. So now what you need to do is this. What are the two events that could happen for each of these band? You either get 7% return in the first case, 7% of the invested amount, which is $10,000. So $700 in one case you get. The other case, if the bond issuer goes out of business, then you lose all $10,000. What is the probability that you lose $10,000? That's 4% chance, or 0.04. What is the probability that you will get $700? 4% chance that they are going to go out of business. That means 100 minus 4 is 96% chance that they are going to stay in business. So you multiply these numbers and add them up. That should give you an answer. That's your expected return from the first bond, and you do the same thing for the second bond. Okay. Next one is uniform distribution. So there is formula for it. So mu is a plus b divided by 2. Okay. And I think sigma square, I forgot the formula. I think it's a minus b whole square over 12. Please check this. Okay. Now you just have to answer these things. So one of the things that you want to keep in mind, that area under the curve, it's a uniform distribution, meaning everywhere is the same, right? So area under the curve must be 1. So that means some event is bound to happen over a window of something, right? This event is bound to happen over a window of something. So if this unit is in this case 240, right? So the height is gonna be 1 over 240. So that's what you want to keep in mind. And then just basically, if it asks what is the probability that the event happens between 0 and 140 minutes, so let's say 0 is here, 140 is here. Okay, so you need to find this area, which is very easy. You know this length and you know the height, so length times height is gonna give you the area, and you do the same kind of things for the other parts. Now let's go ahead and talk about this a little bit. Normal distribution, I may have already made the video for this, so let's just quickly go over it, and you have seen it many times. Excluding extreme values, the income in a city is normally distributed with average income 45,000 and standard deviation 15,000. It came to the next page. Find the probability that x is less than 30,000. So you just have to sketch it here. Mean is 45,000, 45k, and standard deviation is 15k, right? So you need to find the z-scores, x less than 30k. So 30 is somewhere here, 30k. Less than 30 means you're interested in area to the left, right? So probability of x, let's do it somewhere else. Probability of x less than 30, you need to convert it into z-scores formula. 0 mean, standard deviation 1, so there will be a corresponding point here, z, which is going to be something here. How do you go from here to here? Use the z-scores formula. Z is equal to x minus mu over sigma, or x minus x bar over s. So what is your z gonna be here? Z is equal to x is the point in interest 30k minus mu is 45k divided by 9k. Okay, so oh sorry, 15 not 9. Why am I thinking 9? It's probably from the problem that I did in the class. So this is just -1, so z is -1, which is the same as probability of z less than -1. Now you have to look it up in the standard normal distribution table. What is the area associated with z value of -1? You will see it's 0.1587. Okay, and similarly you have to find it for this, and then in this group of problems you are given the z-score. You need to find the corresponding income. So that's easy. Z is equal to x minus mu over sigma, or z is equal to x minus x bar over s, right? So if you know your z, -1.35, and s is the standard deviation 15,000, right? X is the point of interest that you are looking for, and x bar is 45,000. Now you can go ahead and simplify it by multiplying both sides by 15,000 and solving for x. Okay. Actually, these are the ones I did in the video that I made for the second midterm, so I'm going to skip them. Okay. Confidence interval. So let's go ahead and start on the confidence interval a little bit. So let's go ahead and read the problem. In order to get an idea that the true population proportion of iPhone users in the US, Apple surveyed 200 people, randomly blah blah blah, and out of 200, 120 said they use some version of iPhone, right? So create a 95% confidence interval for this. So to create the confidence interval, we need to use the following formula. The formula is, by the way, p hat plus or minus e, where e is the margin of error and defined as e is equal to z sub alpha over 2 times square root of p hat q hat over n. Remember, q hat is 1 minus p hat. So you have all the things that you need. P hat is equal to 120 over 200 and q hat is gonna be 1 minus 120 over 200. N is the sample size, which is 200 here, and alpha z sub alpha over 2. So 95% confidence level, so alpha is gonna be 1 minus 0.95. Remember, that's the significance level, 0.05. So alpha over 2 is gonna be 0.025. Associated with an area of 0.025 in the standard normal distribution, you'd find a z value. Okay, so that's gonna be your z sub alpha over 2 or z sub 0.025. all right, so remember that, make sure that you know how to find this value. Okay, it comes from the z-scores table, or you'll get either positive or negative, right? So let me just give you an idea here so that you can look it up on the table. And this is a standard value, all of you know about it. So this area to the left is 0.025 and this area to the right is 0.025, and that's your z sub alpha over 2, z sub 0.025, and negative z sub 0.025. all right, once you have this, you can find the e value, and p hat is something you already have. So it's going to be, your confidence interval is going to be p hat minus e comma p hat plus e. E is the margin of error that you're going to get from here. Make sure that when you calculate it, is under the square root, the whole thing. P hat q hat over n, this whole thing is under the square root. all right, that's how you do this problem. Oh, one more thing I forgot to tell you here is this: you have to make sure the normality condition holds true. So np must be greater than equal to 10 and nq must be greater than equal to 10. That's probably the first thing you do, is just make sure that you satisfy these conditions. All right, okay, so let's go ahead and continue. By the way, I'm a little bit, not a little bit, actually quite a lot under the weather. Have been sick for the last couple of days, and still you probably have figured it out by my voice and everything. I'm very much suffering from the flu and everything, cough and sore throat. Since I have to make this video, so that's why I'm making it. Hopefully you guys are gonna be able to get what I'm saying. Okay, by the way, this is also the same similar problem. This one, cyberbullying, this proportion problem, same kind of thing. The way you the way you did this one, you do it this way. Okay, now we're going to do confidence interval for situation where when you know sigma, and for that one there is a different formula, and let me write that formula down first. So here again, normality condition, make sure that you take care of this. For all of these problems, you have to ensure that normality condition is met, right? So here the sample size is bigger than or equal to 30, so we're okay. Now your formula is gonna be x bar plus or minus e. E is the margin of error. Okay, and e, by the way, is z sub alpha over 2 times sigma over square root of n. Remember, we know sigma here, so you just do the same kind of thing that we did. Only difference is that you use z-scores table here. While we use z-scores over there too, pretty much sigma is known. Sigma is given, population standard deviation. So here we are doing what? Create a 99% confidence interval. So your alpha is gonna be 1 minus 0.99, which is 0.01, and your alpha over 2 is gonna be 0.005, or 0.01 divided by 2 is 0.005. So alpha over 2 is 0.005, and you need to look it up from the table to get z sub 0.005. Okay, once you have that value, which by the way you will be getting from the standard normal distribution table, okay, and once you have that value, pretty much everything is straightforward. You surveyed 100 people, your n is 100, right? That's your n, and your sigma is given, which is 4. That's your sigma, and you just plug it in here. And x bar was what? 17. Okay, sorry, this is the population claim. X bar is 15, because remember, x bar is the sample mean that came from sample of 100 students that you surveyed here. This is the number that USA Today College reported. That's for the nationwide. Okay, and the difference between this problem and this problem is that in this case you do not know sigma. That means you have to use sample standard deviation S, and by the way, you need to know how to find the sample standard deviation from this, and also you need to find the x bar. So you need to find x bar and you need to find S from this given set of data. Okay. All right, now for this one, again your confidence interval is going to be x bar plus or minus e. However, e here is, we don't use z score anymore, we use student t distribution, t sub alpha over 2 times s over square root of n. You can almost compare these two formulas, and you see here this one versus that one, the margin of error. Z sub alpha over 2 being replaced by T sub alpha over 2, and sigma is being replaced by S. So here we need to make sure that our distribution is of course approximately bell shaped. That's standard given. However, we need to make sure that we use the student t distribution. When you are using student t distribution, remember degrees of freedom, df, degrees of freedom, which is n minus 1, meaning the sample size minus 1. And your alpha over 2 is gonna be, what is it, 95%. So alpha is equal to 1 minus 0.95. So alpha over 2 is going to be 0.025. So if you, when you look at the t distribution table, you should look at area in one tail 0.025, area in two tail double that amount, which is 0.05, and your df, degrees of freedom, is going to be 9, I believe. 1 2 3 4 5 6 7 8 9 10. There are 10 data points, so 10 minus 1 is equal to 9. And you will find x bar from here, you will find s from there. So x bar and s, these are coming from this data set. So you have everything. You have t sub alpha over 2 that you're gonna get from t distribution table. Your s, sample standard deviation, you have it, and n is the sample size, which is 10, and x bar is something you find from this data set. Then you just enter these numbers and it should be fine. Now next problem, let's see. Okay, so this one, confidence interval for population variance or population standard deviation, and here we use chi-square distribution, as you know, and the assumption that the normality holds is a bit stronger in this case, so we need to make sure that it holds true, that population is approximately bell-shaped or normally distributed or Gaussian distribution. Now, having said that, I'm just gonna jump into the problem. You have surveyed 10 students, so your n is 10, right? And 95% confidence interval. So 1 minus 0.95 is 0.05. So your alpha over 2 is going to be 0.025. That means in the chi-square distribution, area to the left is going to be this area 0.025, and area to the right is 0.025. Now remember, chi-square distribution is cumulative from the right. That means unlike normal distribution, which is cumulative from the left, this is cumulative from the right. So you need to find this value. Okay, and to find this value, you do not consider this area. You consider 1 minus 0.025. That is the area to the right of this, which is 0.975. Okay, and your degrees of freedom is going to be n minus 1, which is 10 minus 1, 9, right? So this gives you chi-square sub L, this gives you chi-square sub R. Okay, once you find these values, you plug it in here, plug it in here. You have n and you have s that's given, which is 3. So you just plug in these numbers. That gives you the confidence interval. Alright, hopefully this makes sense. Just look at your class notes, and you should have information there. And also in the class notes I have solved problems, so you could look at the problems that I have solved in the handout, and that should give you an idea of how to solve these problems. And also this video here, I kind of describe how to go about doing it, so you should be able to do it. Next one is hypothesis testing. Again, here we kind of need to make sure the normality condition NP greater than equal to 10 and NQ greater than equal to 10. Alright, so make sure NP greater than equal to 10 and NQ greater than equal to 10. This ensures that the distribution of proportions is bell-shaped. Okay, now having said that, let's go ahead and go through the steps. That way you'll be familiar with how to solve these problems. So here what you're gonna do is this. Number one, you need to make sure that it's bell-shaped, right? You need to do this here. N and P and Q, you know all of them. So number two, your null hypothesis H naught P is equal to 0.5. Actually I meant to say P is less than equal to 0.5. Okay, your alternative hypothesis is HA P is greater than 0.5. This determines which tail are you gonna consider. Okay, if it is greater than, you consider right tail. If it is less than, you consider left tail, and if it is not equal to, then you consider both tails. And step number 3, you'll need to find the test statistic, which I use Z star is equal to P hat minus P hat minus P over square root of PQ. Q is 1 minus P over N, PQ over N. Now P hat is something you have out of 350 you surveyed, 190 said that they have heard of it. So it's going to be P hat is equal to 190 over 350, and P is 0.5, right? So this is 0.5, and then N is 350. So you have all of these numbers, you can plug it in and you'll find the Z value, I mean Z star or test statistic. Now you need to create the critical region, step 4. Now we are considering single tail, right, and which tail? Right tail. So area to the right is gonna be 0.05, okay, because significance level is 0.05. Alright, associated with an area of 0.05, there should be a Z value, okay. This is a 0.05, area to the right. Now you need to find this value. and once you find that value, your critical region is gonna be from that value. Okay, it is, I think, 1.645. okay, 1.645 to positive infinity. So that means from here all the way to the positive infinity is your critical region. Now the value you get from here, that's your test statistic. If it falls within this region, then you'll reject the null hypothesis. This is the null hypothesis. Okay, you'll reject the null hypothesis. On the other hand, if your test statistic that you calculate from here is not in this region, you do not reject the null hypothesis. That means you do not reject that proportion of people who know about this show or have heard of this show is less than or equal to 50% or 0.5. So that's what it is. Okay. So this process that I just described is very standard, and you'd be doing the exact same process for all of the problems involving hypothesis testing. All right. Let's see if I have missed anything here. I do not think so. I think I covered everything. So remember, you need to be able to figure out what is your null hypothesis and what is your alternative hypothesis, and this comes from the statement of the problem. All right, and then you need to be able to figure out how to find the critical region. Okay, depending on which tail or tails you're considering, that's going to determine this thing, the critical region here. Now what if I had my alternative? What if this is not the case? What if it were to be the case that I'm testing for the fact that P is either 50% or not 50%? So in that case, you don't consider one tail anymore. In that case, you're going to be considering two tails like this. One tail to the right, one to the left. That scenario will require you to divide 0.05 by 2. That's going to give you 0.025. So area to the right is going to be 0.025. Okay, and area to the left is going to be 0.025, and that's going to give you one value here, one value here. So your critical region is going to be from here all the way to negative infinity, and from here all the way to positive infinity. And then once you had that, and you do the calculation accordingly and see if your test statistic falls in either of these regions, if it is to the left of this point or to the right of this point. If it falls in either of these regions, you would be rejecting the null hypothesis. Of course, in that case, null hypothesis, so this is going to be, so I'm doing a separate problem, kind of, yes and no. So this is your alternative, and your null would have been, in that case, P is equal to 0.5. So I'm testing that P is 50% or P is not 50%, as opposed to P is less than or equal to 50% versus P is greater than 50%. I'm doing this problem because there will be scenarios where you have to consider both tails. That's why I just want to make sure that you understand and you get a sense of how it works when you have to deal with both tails. Okay, so make sure that you are comfortable with this thing. Okay, now the next problem, very similar, only difference is that I think we are doing it for mean, I guess, right? So let me see what the problem is saying. Oh no, this is the exact same type of problem, for proportion, hypothesis testing for proportion. So whatever I did for the last problem, you do the exact same thing for this problem. Okay, with the numbers changed. So let's go back here. Whatever I did here is exactly the same thing that you'd be doing here, just in a different context. Now this problem is involving hypothesis testing, but for population mean, and in this case your sigma or population standard deviation is known. So that becomes very standard. Again, you have to make sure normality either explicitly given in the problem, or you have to make sure that n is greater than or equal to 30, which it is in this case 100, right? And so number 2, your null and alternative hypothesis, null hypothesis, your alternative hypothesis. So what are you testing? At 0.05 significance level, test the claim that the average number of text messages young adults send is less than 128. So less than, so your mu is less than 128. Remember, to figure out which one is null and which one is alternative, remember that equality, strict equality must always be included in the null hypothesis. So this is your alternative hypothesis, which is that mu, average number of minutes that someone spends, average number of text messages that one sends is less than 128, versus the other one is going to be mu is greater than or equal to 128. See, the equality part is here. Now this should kind of tell you which tail you need to consider. Right away you know it's less than, meaning you have to do the left tail. And your test statistic here is z star is equal to x bar minus mu divided by sigma over square root of n. X bar minus mu divided by sigma over square root of n. You'd need to fill this in. Sigma is the population standard deviation. They have given it somewhere here in highlighted form or bold. So sigma is, so let me write these values here. Sigma is equal to 20, n is equal to 100 sample size, x bar is equal to, what did you find? Average 120. So you have all these things, and of course mu is going to be, you're comparing against 128, right? So you have all these values and you plug it in here, that's going to give you the test statistic. And step number 4, you're gonna find the tail and the critical region. So less than meaning you're doing left tail. Okay, so now this is the point we're interested in, and your significance level, what did they give you? At 0.025. So this area is 0.025, and you'd be finding this value, okay, z sub 0.025, and all the area to the left. So negative infinity to this value. This is technically negative z sub 0.25. That means area to the left. Okay, whatever value you get right here, that's your critical region. Now this test statistic, if it does fall in the critical region, then you will reject the null hypothesis that average is greater than or equal to 128. If it does not fall in the critical region, you do not reject the null hypothesis. Okay, so these are the two scenarios. Excuse me. If your test statistic falls in this critical region, right, then you will reject the null. If it does not, you do not reject the null. Okay, or you fail to reject the null. Now the next problem is the same for mean. You're doing hypothesis testing for mean. However, this time you are doing it for a population for which you do not know sigma or sigma unknown. So in that case, you'll just have to do the same kind of thing that you have done. You have to use S, sample standard deviation, and student t-distribution, and you need to find the x bar and S. X bar is the sample mean and S is the sample standard deviation. Okay. Once, so you just go through the exact same process and assume normality or bell-shaped. Okay, and you write down your null and alternative hypothesis. So what is your null and alternative hypothesis mean? Student works is more than 15 hours. So your now H naught and your alternative H sub A. So mu is greater than 15, the average number of hours students work, and in this case null is going to be the opposite or complement of that, which is less than equal to 15, right? Now what you need to do is this. You need to do the test statistic calculation. I call it T star because we use T distribution. So it's gonna be T star is equal to x bar minus mu divided by, we don't have s, I mean sigma, we need to use s divided by square root of n. Alright, now from the T distribution table, again you'd be finding the critical region. So let's say this is stretched normal distribution, that's kind of like T distribution, and area to the right is gonna be, we are considering one tail, area to the right is 0.05. So area in one tail is going to be 0.05, area in two tails is going to be twice as much, or 0.1. Okay, now degrees of freedom, don't forget degrees of freedom is n minus 1. So from these pieces of information you should be able to find this value, and your critical region is going to be from here all the way up to positive infinity. So let's say your value here is c, I'm just coming up with this number, and it goes from c to positive infinity. Now you calculate this test statistic. If this test statistic does fall in this critical region, you'd reject the null hypothesis that average number of hours student work is less than or equal to 15. So you'll reject this. At what significance level? 0.05. By the way, a significance level is kind of like, you can explain it this way. It's your chances of randomly, if you select a sample, your chances of kind of being wrong. Okay, you can think of it that way. Your chances of being wrong is 5%. Your chances of being right is 95%. Okay, so that's kind of like the layman's way of thinking about it without getting technical or being too technical about it. All right. So that's why if your value test statistic fall in this region, you'd reject the null hypothesis. So that's what the story behind it. All right, so let's see what is coming up next. These problems look like a lot to me. Of course, you guys are thinking probably more frequently, but it isn't. It looks a lot to me because I'm sick. All right, what is this one? Oh, exact same problem. Exact same problem. You use student T distribution. Remember, this is T distribution. Do not use anything else. Okay. Standard process, exactly the same thing that we did right here. Okay, you follow the process and go through the steps. Just if you know one problem, really, if you understand thoroughly one problem in this category, you'll pretty much be able to solve all the problems. They are structurally extremely similar. Structurally, they are extremely similar. So if you understand one, then you understand all of them. All you have to do is just apply it in different context. Now, hypothesis testing for population standard deviation or variance, and in this case, of course, normality condition is very strong. Okay, it has to be bell shaped, otherwise for standard deviation it's not gonna work. So this is a stronger assumption, and your test statistic, which I call chi-square star, is given by n minus 1 times s square divided by sigma square. Okay, now in this case your null hypothesis is sigma square is less than or equal to 4. Your alternative hypothesis is sigma square is greater than 4. Okay, and then you basically calculate this. Remember, sigma square is 4, sigma is 2, right? I'll write it as 4 so that you can just plug it in here. This is something that's gonna go here, and your your S is 2.5 hours, so this is gonna be 2.5 square, 2.5 square, and sample size is given, which is 10. N is 10. So you have everything that you need. Now you need to find the critical region. Are we considering left tail or right tail? Look, this is greater than, so we are looking at this. Okay, so remember this area must be 0.05, and this value, this chi-square value that you are going to get from the table, remember the area to the right is 0.05, and your df, degrees of freedom, is 10 minus n minus 1, which is 10 minus 1, that is 9. Your degrees of freedom is 9, and your area to the right is 0.05. That's gonna give you a chi-square value. Let's say I call it C. Then your tested is, critical region is gonna be from C all the way up to positive infinity. Now once you do this calculation, you're gonna get the chi-square star value. If that chi-square star value falls within this region, that means if it falls from this point on to positive infinity, then you'd reject the null hypothesis. Okay, you'd reject the null hypothesis that population variance is less than equal to 4. Okay, that's what it is. Now next problem is correlation. You'd have to use some sort of device, either use your calculator, regular, or online. If you go and Google or Bing or do Yahoo search or whatever, and look for correlation calculator, you'll find many of them. You just plug in these numbers, you find your correlation R. Okay, when you are doing correlation, remember correlation tells you the strength of association between two variables. Okay, strength of association between two variables. Okay, do not think one caused the other. They don't. There is no causal relationship. There might be, but for you to conclude that, you need to make sure that you do further analysis. Correlation is just an association. One funny example I could think of is this. If you think the number of umbrellas people buy during the rainy season, obviously it goes up, right? The number of umbrellas people are going to buy, but umbrella doesn't cause rain, does it? But there is a strong association between rain and umbrella, so you kind of have to think of it that way. Just because something happens doesn't mean that's the reason. Like people do a lot of shopping during the Christmas time, okay, during the end of the year. Well, I don't know if that's a good example. I was just trying to make up something. I got another great example. I heard it somewhere. So like right now is a good example, and I'm a victim of it. So let's say certain time of the year causes people to get sick, right? Like I'm sick right now, and that doesn't mean that weather condition causes you to get sick. It might be the case that weather condition causes you to that weather condition somehow makes certain bacteria more active. So that bacteria causes flu or whatever, right? But the weather condition in and of itself does not necessarily make you get sick. Even though if you find correlation between temperature or let's say certain factor of weather and getting sick, you'll find a strong association. Whereas from that, people tend to think, oh yeah, that's probably the reason or that's the cause for getting sick. No, that is not the cause. That's a stronger association. Why am I talking about this thing too much? Because this is something very common in our life, and yet many people tend to confuse causation with correlation. Causation and correlation are not the same thing. Causation means something is the source or cause of something. Correlation just means, oh, there is a strong relationship between these two. Okay, these two variables or these two things. All right, enough of correlation. Next is what is next? Oh, looks like we're done. Oh, no, that wasn't too bad. The next thing is regression, linear regression. We are going to talk about linear regression here. So again, you will have to use some sort of device. In this case, some of you are using calculator, but I recommend you using the online software. Just Google linear regression calculator and go there and plug in these numbers. Remember, you may want to make sure that you enter the variables properly. One is x independent variable, y dependent variable. Okay, so this is the predictor and this is the predicted value. Okay, independent variables, sometimes we call it target value, but whatever the thing that they say, you need to make sure that your independent variable is put under the x and dependent variable is put under the y. In this case, what is it? Oh, this is also correlation. Sorry, I just jumped ahead. I meant to talk about this. So this is correlation. So just to do the same thing that you did here. Linear regression is this one. So make sure that your independent variable is x and dependent variable is y. So independent variable here is the amount you spend, like 20, 10, 35, okay? And your dependent variable is the tips, 3, 0, 5. Because the amount of tips people pay really depends on the amount of money generally they spend. So there is a strong correlation between these two. So what our objective here is to find out a straight line that best fits this data set. That's what the regression means. Okay, you are finding the best fit straight line because we are assuming that the relationship between these two variables is linear, and that's why we call it linear regression. Guess it's no surprise, right? It's linear regression. Now, straight line relationship. We talked about it in the class, and we talked about how we find that line. We are minimizing the sum of squared error or average sum of squared errors. And that's how we find the best fit line or regression line. And of course, conceptually what happens is something we talked about in the class, but in reality you do not do that calculation by hand. You use a calculator or some software, and if you plug in these values from in an online application, you should be able to find the regression line. Y hat is equal to ax plus b. This is like y is equal to mx plus b. Okay, now a is the m slope and b is the y-intercept. So you will get these values, and once you get these values you can predict y value. So from this data point, objective here is to create a best fit line or regression line from these data points and predict the tip amount for the future expenditure at the restaurant. So somebody comes in next time, spends $50. What can you expect that person to pay in terms of tips? So this model will tell you that. And let's see what else. Okay, once you get the model, I give you these two values, and I talked about it in the class as well. This one you can predict using this, but this one you cannot, because normally the rule is that you can predict y values for x that falls within the range of the given data set. So that means within the range of the x values for this given data set. So that's something that you need to be careful. This is sort of like a trick question. When people are working on this, they'll be like, oh yeah, I found, so let's say you got something like y hat is equal to 0.25x plus 3. I just made it up. This is not the regression line for this, okay? I just made it up. So they would say, okay, for x equal to 50, I'm gonna put 50 here for x, okay, and simplify it. And then they're gonna say, oh yeah, for x equal to 210, I'm gonna put 210 here for x and simplify it. Oh, by the way, this number is not within the range of x values. X values has a range here. I think it's from 10 to something like, what is it, 85? Oh, 200. Okay, but 210 falls out of this range. 210 falls out of this range. So you will say we cannot do this calculation. We can't. Why can we not do it? Because this x value does not fall in the range of x values given. So that's what it is. All right, hopefully that helps. Sorry folks, I wish I could do a better job in making the video, and as I said, I'm a little under the weather. Hopefully this is helpful. If you have any question, don't hesitate, email me. I'm available by email. I'll be happy to answer your questions, and your final exam is still a few days away, so you have time. And go over this video and let me know if you have any questions, and good luck to you, and wish you a successful final exam in statistics. All right. All right, thank you.